Okay, I need to find the equivalent resistance seeing from here. So first what I will do, there are some series and parallel combinations in this arrangement, and what I will do, when two resistances are in parallel, we know the equivalent is like this: 1 over Rp will be 1 over R1 plus R2. So we can actually arrive to a formula like this one: R1 plus R2 is 1 over Rp. So Rp is equal to R1 times R2 over R1 plus R2. This is something we will often need for this problem and for later on any problem whenever we are doing equivalent resistance problem, minimizing two parallel resistance into one. uh, so we will need this. So I will just use, I'm just written it here, this formula, and I will be using it. So now in this particular circuit, what we have is, we can see that there are this one and this one. So basically I will just draw, these two are in parallel, and these are the first one. Otherwise we don't see any parallel element at this moment, but we have to start minimizing first. So these two are in parallel, so we can replace these two by one. So just one resistance that will replace them. So let's draw the circuit first, redraw it with that one replaced by just one resistance. So every other resistance's value stay the same: 1 ohms, 20 ohms there, 2 ohms there, and then 16 ohms there, 18 ohms there, 9 ohms there. Everything else is same. This one will be the parallel combination of this. So 20 and 5, so 20 times 5 over 20 plus 5, which is 100 over 25, that is 4 ohms. So we have that. Now we can see that these two are coming in series, these two resistances. So 4 and 1, this is 5 ohms. So what I will do, instead of redrawing the whole thing, I will just replace this part, this part with one resistance. That's 4 plus 1, which is 5. So basically I'm erasing this one, and then I have erased the 20 ohms as well, but I will write it again. So 5 ohms here and 20 ohms here, and this one is going there. It could have gone here as well, because these 2 points would be the same anyway. So now again we have this 20 ohms and this 5 ohms in parallel. So I will redraw this one. So first this one stays there, this one stays there, this one stays there, and this one stays there. So we have 16 ohms, 8 ohms, 9 ohms, 18 ohms, 9 ohms and 2 ohms. So 16 ohms, 18 ohms, 9 ohms and 2 ohms. These do not change. Only these two we have to find the equivalent parallel. So 20 and 5 again. So 20 times 5, 20 plus 5 over 20 plus 5, which is again 4 ohms. So we have 4 ohms here. So now we can see that these two are again in series. So we can write, instead of that one, we can write one resistance, 4 and 2 in series, so that's 6 ohms. So we will just write 6 ohms there, replace with one resistance. So this one will be 6 ohms there. So now we can see that these three are coming in parallel, and we have to find the equivalent resistance there. So what we can do, we can do this 1 over 18 plus 1 over 9 plus 1 over 6 over is equal to 1 over R equivalent kind of thing, or RP, whatever. So otherwise what we can do, which will probably be quicker, we don't need a calculator that way, but we can just plug in these values in the calculator and find them right away. That's also another way, but in this case I won't do that. What I will do, first I will find the equivalent of this one, because I can see that will be a simpler one. So 18 and 9, 18 times 9 over 18 plus 9. So that is 18 times 9 over 27, which is 3 here and then 6 here. So basically 6 ohms. So these two parallel can be replaced by a 6 ohms there, and there is a 6 ohms there, and we have 16 ohms there. So now we have reduced it much. So we have 6 ohms, 6 ohms in parallel, these two, and whenever two equal resistances are in parallel, the equivalent is just half of that. It's always there, always it will happen. So here we can see just 6 times 6 is 36 over 12, which is 3. It should be 3. So we have now 16 ohms here and 3 ohms there, just in series. So it's a very simple arrangement finally, and we replace it with just one resistance, which is 19 ohms. So that is the equivalent resistance that is seen from this side. So 19 ohms is the result.